Trigonometry. I'm Mrs. Ward. I am sorry that I cannot be there with you today, but we're moving my daughter into her college dorm, so I am not able to be there. So welcome to trigonometry. If you remember from last year in Algebra 2, trigonometry is the study of right triangles. So that's what we're going to be spending pretty much the first quarter on, is looking at right triangles. So before I get too far into trig, I do want to remind you that you do have a summer learning. We did push back the date. The date that these are due is now August 23rd. Just a refresher course, you go to Blackboard. When you go to your classes, you are looking for Senior Math Prep 2018. You have 4 units. You're supposed to do the 4 units and take a quiz. Those will be graded. We will pull those on August 23rd at 5 o'clock, and it is worth 10 points in academic achievement. If for some reason you cannot see this, you need to email me as soon as possible. I will be checking my email over the weekend. If you have a question with one of these sections, you can also email me as well. So now let's get into the fun stuff, and let's start talking about trig. So what our goals for the first section is going to be to describe angles, use radian measures to describe angles, look at the degree measure and convert between radians and degrees, use angles to model and solve real-life problems. So this is everything that we're going to cover in 4.1. We are going to be able to look and label the parts of an angle. We are going to be given what's called a unit circle, a blank unit circle, and we are going to be able to fill in the measures of the angles both in radians and degrees. We will be able to convert from radians to degrees and from degrees to radians. We will eventually find coterminal, supplemental, and complementary angles, and then we will convert between degrees, minutes, and seconds to what's called a degree decimal. And then we will solve problems. So that's what this whole 4.1 section will be. If you are an overachiever and you'd like to look at your trig class, I'm a big fan of doing the calendar. So if you look at the website, so eventually we're paused. Okay, so if you look at the website, chapter 4, it's kind of like flip learning, flip mastery. So you have chapter 4. Here, if you click on this, this will be your chapter 4 textbook, an online version. So if you don't want to carry your book, you will always have that at home. This section will, when I click on 4.1, it'll give me the notes. Those are note sheets. These will be the actual notes that we take in class. Here's another video. So in case you don't like my video, you can watch Mrs. Kelm. This is what we're doing today, the vlog part 1. This is what we'll do next class, vlog part 2. And then this will help us with the review. These will be reviews that we'll eventually do later on before we take the quiz. But I also put everything on a calendar. So when you look on the calendar, eventually, your classes will be color coded. These are my classes. Your 4.1. You're just going to have to keep track. So this 4.1 assignment was both for my blue and gold days. You will notice that this is always on the day that it is due. So this homework assignment, since we're learning it here today, this homework assignment will be due on the 21st. If you click on it, it'll list out the actual page number and problems that you have to do. That will also, all that information will also be in Plus Portals as well. So there are 2 places that you can find your homework if you have any problems. I do have a policy sheet, but today with me not being there, I just figured it'd be easier to give you the policy sheet when I see you on Tuesday. So you'll get that policy later on. So now we're going back. So that's what our goals are. So before we get started though, we do have, we're going to have to do a lot of work with fractions. So this is part of your summer learning, was to review how to add, multiply, subtract, multiply, and divide fractions, and how to rationalize a fraction. So remember, when you add 2 fractions, I'll just do the first one, I'll give you a second. So when I add the fractions, I have to have a common denominator. So what I'm going to have to do is I'm going to have to ask myself, what's the lowest number that those 6 and 3 will go into? And you say 6, so the 1, 6 stays the same. Then the 3, in order to make it a 6, I would multiply it by 2. If I multiply my denominator by 2, I have to multiply my numerator by 2. So I take 1 times 2 and get 2. 3 times 2 and get 6. Remember, when you multiply fractions, you multiply the numerators, multiply the denominators. Now, when I add fractions, my denominator will stay that 6. And I add 1 plus 2, and I get 3. And lowest terms, that'll be 1/2 because they're both be divisible by 2. Just a quick reminder, when you rationalize fractions, you look at whatever's in the radical sign in the denominator. And by rationalizing the fraction, that means you're basically removing the radical sign from the denominator. So I'm going to multiply the denominator by the square root of 2. Whatever this number is, that's what I'm multiplying it by. So if I multiply the denominator by the square root of 2, I multiply the numerator by the square root of 2. Because when I multiply by the square root of 2 over the square root of 2, I'm basically multiplying by 1. And I can multiply anything by 1 without changing the fraction. When I multiply, I take 2 times the square root of 2, which I write as 2 times the square root of 2. I cannot make that 4 because 1 is under the radical sign and 1 is not. So they are not like terms. I cannot multiply them. I take the square root of 2 times the square root of 2. They are both under the radical sign, so I can take 2 times the 2 and get 4. Well, the square root of 4 is 2. So the square root of 4 becomes 2. These simplify. And now I end up with just the square root of 2 over 1 or just the square root of 2. So whoever's running the video, if you would kindly pause it and give your classmates about 5 or 7 minutes to complete the remainder of the problems, and then we'll meet back and compare answers. Okay, welcome back. Here's the work for the problems. So for number 2, I got -1/6. For number 3, I got 1/18. For 1/4, remember when I'm dividing fractions, I multiply by the reciprocal, the second fraction. So I took this 1/3 and I flipped it over and made it 3/2. I end up with 3/2. The last one, 3/4 plus 4/4, I get 7/4. In trig, we leave them as improper fractions. We do not change them into mixed numbers. So even though the numerator is larger than the denominator, that's okay. I leave it like that. Now, a case like this, when it was 3/6, I still have to put in the lowest terms. But if it's an improper fraction, it's going to be easier for me to just leave it as an improper fraction. Okay, number 2, I have the square root of 2 over 2. 3 times the square root of 2 over 2. 4 is the square root of 3 over 3. And 5 is 2 times the square root of 3 over 3. If anyone has any questions and they want to talk about this, I'll pause the video and see if somebody in class can help you out. If no one can help you out, then just circle it, put a star by it, and I'll make sure we go over it next time I see you. Okay, so this is what we're going to cover today. We're going to talk about variables for angles. The variables for angles that we use in trig are alpha, which looks like that, kind of looks like a incomplete infinity symbol. Then we have beta, which is like a B with a T. And then finally you have theta, which your generation says it looks like a Pokemon ball. So those are the 3 variables that we most commonly use for angles. And then we are going to start by drawing some angles in standard form. So here's a picture that I had on the first page. This is an angle drawn in trig. We have parts to the angles in trig. So when I look at this angle here, the first side, when I make an angle, I have 2 rays. One side I'm going to call the initial ray. So this will be called my initial side. And what I notice about the initial side is always on the positive x-axis. So every angle that you draw in trig, it will start with your first line being drawn from the origin on the positive x-axis, so pointing towards the right. Then my second ray that makes up the angle is, in this case, is here. That's going to be what I call the terminal side. Then I have this angle alpha, which when I draw the angle alpha, it starts at the initial side and it is going up. So it is going counterclockwise. So this black line, the way I've drawn it, and when I draw angles in trig, I have to make sure that I have this directional angle to show me which way my angle is going, because I'm not sure if I went this way or if I went the other way. So this angle, this black angle, that is going to be a positive angle because I went counterclockwise. You can see that I have this angle called beta. Beta, I start at my initial side, and this time I go in the opposite direction. So I'm going clockwise. And when I go down, so when I first go down to draw this angle, that becomes a negative angle. So if I go up, it's a positive. If I go down, it's a negative. If I'm going counterclockwise, it's positive. If I'm going clockwise, it's negative. Since these angles, both alpha and beta, have the same initial side and the same terminal side, they're called coterminal angles because they share the same terminal angle. Every angle in trig will have the same initial angle because, or the same initial side, because they all start on the positive x-axis. So if they happen to have the same terminal side, they're called coterminal angles. Okay. Now let's talk about degrees. If degrees, I think, are fairly simple because you've been doing degrees pretty much ever since you've been doing math. So if I have this circle and I want to start here with my initial side and go all the way around the circle, and I asked you how many degrees that would be, most of you would very easily say, well, that's 360 degrees. 360 degrees, that's fairly simple. If I ask you if I'm going starting here, always starting here, this is my initial side, and I only go halfway around the circle, then you should realize that half of 360 would be 180 degrees. If I ask you how many degrees fits 1/4 of the way around the circle, so here I'm starting on my initial side again, and now I'm going to do 1/4. So I'm just doing like the first quadrant, this angle here. So that makes it perfectly right, drawn right angle. So that is going to be 90 degrees. So if I asked you what quadrant is an angle with 30 degrees, well, if you think of it this way, if I had an initial side here and a terminal side here, you would say that would be 0 degrees. The angles are right on top of each other. This angle we just said was 90 degrees. This angle here we said was 180 degrees. And then we also said that going all the way around the circle was 360 degrees. Then I have to help myself out, I'm going to label this one, which I haven't done yet, this angle down here, which divides my third and my fourth quadrant. Remember, it goes first quadrant, second quadrant, third quadrant, and fourth quadrant. So this angle here that starts my fourth quadrant, ends my third quadrant. So if this is 180 and I go 90 more degrees, so 90 plus 180 will be 270 degrees. So I like to think of the 0, 90, 180, 270, and 360 as like the barrier. So if I'm asking myself what quadrant is an angle with 200 degrees, so what quadrant is 210 degrees in? Well, I know 210 is more than 180, so I know it's more than 180. What's the wrong color? Oh, what a mess. My. I'll just erase all that. Okay. So I know it's more than 180. I know that 210 is less than 210. So that has to fall somewhere in this area here. So to answer this question, and I don't have to know exactly where that angle is, it's just asking me what quadrant is it in. I'm going to say the 210 is in the third quadrant. Just a refresher, you need to name your quadrants with Roman numerals. Remember, they start first quadrant, 1, 2, 3, 4, and they go counterclockwise, which is supporting this trig idea that a positive angle goes in counterclockwise direction. So I hope that's clear. Then we're going to do radians. Now radians, if I think about radians, if I asked you, let's suppose I had a radius of 1, just 1, and I asked you what the circumference of a circle is. Well, the formula that you learned for circumference is equal to 2 pi r. So in this case, my circumference would equal to 2 times pi times 1. So the circumference of the circle would equal 2 pi. So when I do radian measures, instead of looking at the angle that's formed in here, the radian measure is looking at my arc length out there. So it's asking me what fractional part of this circle do I have. So if I went all the way around the circle, then that's going to be what I call 2 pi, because that would be the circumference of my circle. If I go halfway around the circle, so if I start here and I only go halfway around the circle, it's going to be half of that 2 pi, so it's just going to be 1 pi. Now let's see if we can think. It's not written here, but let's think a little bit. If I want to just do a quarter of the circle, so I want to start here and do the arc length up until right here, so separating my first quadrant, that's going to be 2 pi. That's going to be half of this pi, which would be what I call pi over 2. Half of pi would be pi over 2. So then, if I wanted to find this dividing mark down here, I'm going to take 1 pi, so 1 pi, plus half a pi, so 1 half pi. I would never write like this, but I just want to just forget about the pi for a second, so I'm just going to leave it there. What's 1 plus 1 half? So 1 plus 1 half would end up being 3 over 2. So this will be 3 pi over 2. So I'm going to write this as 3 pi over 2. So those are my boundaries for my quadrants. So any angle in the first quadrant will be between 0 and pi over 2. Any angle in my second quadrant will be between pi over 2 and pi. Any angle between pi and 3 pi over 2 will be my third quadrant. And the fourth quadrant will be 3 pi over 2 and 2 pi. But if I asked you what quadrant is, let's say, 7 pi over 6. So I have to ask myself, the easiest way I do it is, I ask myself 7 pi over 6. I ask, is it more than 1 half? Well, 7 is larger than 6, so I know it's more than 1 half. In fact, I know that it's more than 1. So I know this is more than, it's going to at least be in the third quadrant. I want to know if it's in the fourth quadrant. Is that 7/6 larger than 1 1/2? And no, it's not. And if you're not sure, you could do on your calculator 7 divided by 6 and get a decimal. If it's not larger than 1.5, then you know that this angle is in the third quadrant. So that's how you do it with radians. So now you're going to have, right now you should be passing out a blank unit circle. And what we're going to focus on today is you have these ordered pairs on the outside. We're not going to focus on those. I'm just going to do the first 2 quadrants and ask you to fill in the rest yourself. So let's do what we call the main one. So this here is 0 degrees, or 360 degrees. We already said that. We said this angle up here, which is 1/4 of my way around, would be 90 degrees. This angle here we said would be 180 degrees. This one we already said was 270. And you'll notice for this quadrant here, you always have 2. So this will be 0, and I put the 360 in the wrong place. This will be 0 and 360 degrees. So now when I go to do radians, I'm going to still keep it black. This is still going to be 0 radians, or 2 pi radians. This one we said was pi over 2 radians. This was pi. This was 3 pi over 2. And then I ended with 2 pi. So now you'll notice that we have special angles drawn, so special lines drawn. So let's talk about the blue one, because I think the blue one makes more sense. The blue one is halfway between these 2 black lines. It's halfway between. So half of 90 degrees is 45. So this angle here is 45 degrees. So from here to here is 45 degrees. From here to here is 45 degrees. Well, 45 plus 45 is 90. If I take 90 and I add another 45 degrees, I'm going to get 135 degrees. And then I add 45, I get 180. Add 45 to that, and I get that number. Fill that in yourself. Add 45, I get 270. Add 45, I get this other number. Add 45, and I get 360. So I've just sort of mentally worked my way around the unit circle. Now, when I do it in radians, well, what's half of pi over 2? Well, what's half of 1/2? That's going to be pi over 4. So every line that's blue is going to have a denominator of 4. So this one over here is going to have a denominator of 4. This one down here is going to have a denominator of 4. This one over here, denominator of 4, because this is separating, these are doing my quarter chunks. So this is 1 pi over 4. This is 2 pi. So this is 1 pi over 4. This is 2 pi over 4. So if I take 2 pi over 4 and add another pi over 4, I get 3 pi over 4. This is 4 pi over 4. Then this one would be adding 1 to 4. I would get 5 pi over 4. 6 pi over 4. 7 pi over 4. And then finally 8 pi over 4. Whoops, I did too much of that. Sorry about that. So now when I look at the green and the red, each one of those is separating my circle. The green, each one of those is from here, I have, like, I go 1, 2, 3. So I have a third. Each one of those is 1/3 of that pi over 2. Or if I think of it this way, I have 1, 2, 3, 4. So I skip from 1, 2, 3, 4, 5, 6. So each one is 1/6 of the circle. So if I look at the radians first, because the radians might actually be easier to do, this would be pi over 6 because it's 1/6 of that pi. Then this would be another 6, so 1/6 plus 1/6 would be 2/6. 2/6 would be pi over 3. So everyone with a red line is going to have a denominator of 3. Everyone with the green line is going to have a denominator of 6. When I count, this is 1/6, 2/6, which simplifies to 1/3, 3/6, which simplifies to 1/2. Then this would be 4/6. Well, 4/6 simplifies to 2 pi over 3. So that's 4/6 plus another 6, so that's 5 pi over 6. 6 pi over 6, and then you can finish working around the bottom. When I do the degrees, it's 1/3, 1/6 of 80. Well, 180 divided by 6 is 30, so this is going to be 30 degrees. And then keep on adding 30 degrees. 30 plus 30 will give me 60. 60 plus 30 gives me 90. 90 plus 30 will be 120. 120 plus 30 will be 150. 150 plus 30 is 180. Keep on finishing around. So part of your homework tonight is to finish these last couple spots. So I need this. I need these last couple spots. And I'm sure if you Google, it's called a unit circle. If you Google unit circle, you will find they're out there. There's millions of them. But I kind of want you to figure out the process of doing that. And then the last thing we have to do is we have to convert between radians to degrees and degrees to radians. So 1 radian, if we go back to here, 1 pi is equal to 180 degrees. So I am going to use that special ratio that I see right here. I'm going to use that special ratio. I'm going to use that to convert between radians and degrees. So if I take my degree and multiply by pi over 180, I'm going to get a radian. So let's say I had 210 degrees, and I wanted to change it to radians. So I'm going to take 210 degrees over 1 times pi over 180 degrees. I believe if you use units, you can see that the units of degrees would simplify. So I'm going to end up with 210 pi over 180. And then I would put that in lowest terms. And if you're not a big fan of doing lowest terms, on your calculator, a quick cheat is if you take 210 and divide it by 180 on your calculator, leave the pi out of it, because once you put that pi in it, you're going to get decimals. Leave that pi out of it, you should get 7/6. So your answer will just simply be 7 pi over 6. And that's changing from degrees to radians. So it's 210 degrees is 7 pi over 6. So when you go back to your completed unit circle, you should have a 7 pi over 6 and 210 degrees here. You should, I hope. Now let's go the opposite way, where I give you radians and I want you to change it to degrees. You're still using the 180 over pi, but now you flip it. And the reason why you flip it is, again, if you talk about your units and simplifying, you're going to want your pi symbols to simplify. So if I have let's say I have 11, I don't want to do 11 pi over 6. I want to do 5 pi over 3. And I want to change that to degrees, so I'm going to multiply by 180 over pi. It's always going to be 180 and pi. It's just a matter of whether the pi is on top or the pi is on the bottom. When I think about this, though, now these pi's will simplify. So they're kind of like my units, and they will simplify. If you're not a big fan of, mental math, you're taking 5 times 180, you're dividing it by 3 on your calculator. Or you could simplify before you multiply. Either way, you're going to get 300 degrees. So that's how you change from radians to degrees. So again, if this wasn't enough information and you want to watch more, you can go on Blackboard, and there are 2. You just need to watch the first video, that first vlog. If you want to do that, you can do that. Otherwise, you should be good to go. And your homework is right here, just page 265. We took it easy on you tonight, just those numbers. If you have any questions, email me, and I hope this helped.